The use of robots for search and rescue was first discussed in the 1980s, but it was not until the 2001 World Trade Center collapse that robots were actually used in a disaster. The breakthrough was the shift to small tactical robots that could fit into voids where people or dogs could not physically enter. Since 2001, land, sea, or aerial vehicles have been deployed to 26 documented disasters in the U.S., Japan, as well as to China, Haiti, Italy, and New Zealand. The majority of ground robot deployments have been for underground mine disasters. Marine vehicles have been used almost as frequently as ground vehicles, and ground vehicles have been used twice as frequently as small aerial vehicles. Robots have been primarily used for searching for survivors, where better human-robot interaction is needed to offset the loss of depth perception and unusual viewpoints. They've been used for reconnaissance and mapping, where mobile manipulation of doors remains a challenge. Robots are used for inspection of buildings, where image stabilization, resolution, and photogrammetrics are essential for accurate assessment. Marine vehicles are used for structural inspection of bridges, where surface vehicles can use wireless networks but must function in GPS shadows where the signal is lost. Current autonomous underwater vehicles can cover large areas, but lack the obstacle avoidance capabilities needed to operate in debris-filled water or near structures. Robots have never found a living survivor, as they arrive on average 4.5 days after the event, while most trapped victims die within 2 days. But this will change as robots are being adopted by the rescue community. 15 of the 26 deployments have been by the Center for Robot-Assisted Search and Rescue at Texas A&M. Our observations are that ground robots are almost always tethered for 2 reasons. 1. Wireless networks are unreliable in dense rubble with metal rebar, in mines, or inside commercial structures such as nuclear power plants. And 2. Most voids and entries are made from above, with the robot trying to penetrate down into the rubble. Another surprise is that mobility has not been the major barrier. It has been sensing. Dirt, mud, water, smoke often interfere with and coat the sensors. Unmanned aerial vehicles must often operate within 3 meters of a structure in order to get the views needed by structural engineers, and thus need obstacle avoidance and better human-robot interaction. Please join the Roboticists Without Borders program and help us help society through robotics.